Welcome to Sri Krishna Educational Channel. Please like, share and subscribe my channel. So in this video I am going to discuss about alcohols, phenols and ethers. Previous video I have already explained about the nomenclature structure of the alcohols, phenols and ethers. This video I am going to discuss about the preparation methods of alcohols. So in this the preparation of alcohols. So alcohols can be mainly prepared by the four methods. First one from the alkenes to alcohols. Second one from the carbonyl compounds to alcohol, and third one from the Grignard reagent to alcohol, and the fourth method is the fermentation method, by the fermentation of different kind of substances. That case we can get the alcohols. So in this first one is from the alkenes. When the alkenes which undergoes hydrolysis in presence of the acid, so that case we can get the alcohols. So here the addition reaction which can be takes place. So the H2O, it can be added one of the hydrogen H plus and other one of the carbon H plus is added, other carbon which only OH minus can be added. So as a result the alkene can be converted into alcohol. So now in case of the symmetrical alkenes, so the addition reaction which can be takes place, whereas in case of the asymmetrical alkene, so that case the addition which can be takes place according to Markovnikov's rule. So the alkene, in that alkene, the carbon which has less number of hydrogen, to that the OH group can be attached. The carbon which has the more number of hydrogen in case of the alkene, so that case the hydrogen can be added. So this is the Markovnikov's rule. So according to Markovnikov's rule, the addition of the water molecule takes place for the unsymmetrical alkenes. Here the mechanism of this is very important. So in the case of the mechanism, it is mainly consisting of the three steps. First one is protonation of alkene. This protonation which can be obtained from the acid. Proton can be obtained from the acid. When the acid H plus, which is a water molecule which can be reacting with the acid, so that case it can be forms H3O plus can be obtained. Now from this H3O plus, which can be reacting with this alkene, the double bond which can be attacks on the hydrogen of the alkene, so the water molecule can be leaved out, so that the double bond consisting the carbons, one of the carbon gets hydrogen, one of the carbon gets the hydrogen, other carbon gets the positive charge. Next step, the nucleophilic attack. So in this case, the water molecule which is obtained here, this water molecule consisting the oxygen has a two pair of electrons. So these two pair of electrons, oxygen has acts as a nucleophile. So this which can be attached on the carbon which is having the positive charge. That case it can be forms the hydronium ion of the particular carbonyl, particular alkene. Now the third step, when this alkenes consisting the hydronium ion, so which can be lose the H plus, by reacting with the water. So in the water the H plus can be obtained. So that case it can be forms the alcohol, and which also releases the H3O plus. So this is the three-step mechanism. First step is the protonation. The second step is the nucleophilic attack by the water molecule on the carbocation. Third step is deprotonation from the alcohol. This mechanism is important. Next one, by the hydroboration method. So in this case, the hydroboration we need to use the diborane, that is B2H6. When the B2H6 which can be decomposed to give 2 moles of borane, that is BH3 can be obtained. Now this borane which is treating with propane, so that case initially it can be obtained the hydrogen added to the alkene propene. So hydrogen added to the second carbon, that means second carbon, whereas the BH2 which is added to the first carbon of the alkene. So whatever the number of hydrogens which are present on the case of this borane, so that many number of addition reactions which can be takes place to the alkenes. So the another molecule of propene which is treating with this compound, that case we can get the another addition product. So the this borane which is having only one hydrogen, so it can be further reacting with the one more propene. So that case we can obtain the three propyl groups which can be attached to the boron. So now this compound tri-N propyl borane which is undergoes the hydrolysis in the presence of the peroxide, hydrogen peroxide, and as well as the base, strong base like sodium hydroxide. So that case which will gives the primary alcohols, that case which will gives the primary alcohols. So selectively we can obtain the primary alcohols by the hydroboration method, by the hydroboration method. It is a important name reaction. Okay, previously we can get the unsymmetrical alkenes, so from that we can get the secondary alcohols, okay, whereas the hydroboration method we can get the primary alcohols. Okay, next we can also get the alcohols from the carbonyl compounds, okay, that may be aldehydes or ketones. So when the aldehydes or ketones which can undergo the reduction, okay, which can undergo the reduction, so here we can use the reducing reagents like the sodium borohydride or lithium aluminum hydride, or hydrogenation in the presence of platinum, palladium or nickel. So that case which can gives the corresponding alcohols. When the aldehyde RCHO which is undergoes hydrogenation in presence of palladium, so that case we can obtain the primary alcohol. Whereas when the ketone RC double bond O R dash, so which is undergoes the treating with the sodium borohydride, so that case we can get the secondary alcohol. So when the aldehydes undergoes reduction, that case we can get the primary alcohol, whereas when the ketones undergoes reduction, okay, we can get the secondary alcohols. Here the main reagents which can be used, the reducing reagents, okay, lithium aluminum hydride, sodium borohydride, or hydrogenation in the presence of platinum, palladium or nickel. Next, by the reduction of the carboxylic acids, okay, carboxylic acids also can be converted into the alcohols, okay, by using the strong reducing reagents like lithium aluminum hydride. So in presence of the lithium aluminum hydride, so that case it can be reduces the carboxylic acids into alcohols. So here the carboxylic acids will be converted into the primary alcohols. Okay. In case of the esters, okay, when the esters, okay, which undergoes esters, okay, which also undergoes the hydrogenation in presence of the catalyst, so that case also we can get the alcohols, that case also we can get the alcohols. So this is from the carboxylic acid. So this is another method, okay, that is the fermentation method, okay, fermentation method. So in case of this fermentation method, so the sugars, when the sugars, that is C12H22O11, this is the molecular formula of sugar, okay, when it is undergoes hydrolysis in presence of the invertase enzyme, okay, it is an enzyme catalyzed reaction. In presence of the invertase enzyme, it will gives the 2 moles of, okay, 1 mole of glucose and 1 mole of fructose can be obtained. Those are having the same molecular formula, glucose and fructose. Now the glucose or fructose, okay, when it is treating with the Zymes enzyme, so that can be converts these glucose or fructose into alcohol. In addition to that, which can also obtain the carbon dioxide gas. So this is the fermentation method. This is the fermentation method. So by using the different kind of food product, we can easily obtain the alcohol, okay, when it undergoes, when it is treating with the enzymes, that is initially the sugars which are reacting with this invertase enzyme, which can be gives the glucose and fructose. Now the glucose or fructose which is treating with the Zymes enzyme, so that case we can get the ethanol. So this way also we can get the alcohols. Okay, next the last method, that is from the Grignard reagents. Okay, when the Grignard reagents which are treating with the carbonyl compounds, it may be aldehydes or ketones. So when it is treating with the carbonyl compounds, okay, that case which will give the adduct, initial adduct. So further which is undergoes hydrolysis, that case we can get the alcohols. So here the Grignard reagent, which is nothing but alkyl magnesium halides, those are known as the Grignard reagents. So in this case the alkyl group is having the partial negative charge, whereas the magnesium having the partial positive charge. So which can be the alkyl group which can be attack on the carbonyl carbon, so that the double bond between the carbon and oxygen which can be moved towards oxygen. So that case we can get the adduct. So in the case of the adduct, the carbonyl carbon which is attached with the alkyl group, and the oxygen of the carbonyl group, okay, which is attached with the magnesium halide. Now when it is undergoes hydrolysis, that case which will gives the cleavage which can be takes place between OMgX and hydroxy group can be obtained. So in case of the formaldehyde, that is methanol. So when the methanol is treating with alkyl magnesium halide, so that case we can get the primary alcohol. That case we can get the primary alcohol. Whereas when the alkyl group consisting aldehyde, okay, like acetaldehyde or propanaldehyde, so that case when those are treating with the alkyl magnesium halide, okay, followed by the hydrolysis, so that case we can get the secondary alcohol. That case we can get the secondary alcohol. And when the ketones, okay, those are treating with the alkyl magnesium halide, Grignard reagent, followed by the hydrolysis, so that case we can get the tertiary alcohol. 3-degree alcohols can be obtained. This way we can get the alcohols from the Grignard reagent. Okay, these are the preparation methods. Next, some physical properties of alcohols. Here the alcohols which are consisting the alkyl group as well as hydroxy group. So the properties okay, which can be mainly due to the presence of the OH group, okay, and it also depends on the nature of alkyl group which is present on the alcohol. In this first one is the boiling points of the alcohols. The boiling point of alcohols which should become increases with increasing in the number of carbon atoms. As the number of carbon atoms increases, then the boiling point of alcohol that should become increases. So that is due to increasing van der Waals forces. So in case of the alcohols, the boiling point that should become decreases with increasing branching carbon chains. In case the branch carbon chains are present, so that case the boiling point that should become decreases. That is due to the decrease in the case of the van der Waals force of attractions. And it is interesting to note that the boiling point of alcohols which are higher in comparison to other class of the compounds like hydrocarbons, ethers, okay, haloalkanes. So when comparing with these, okay, the boiling point of alcohols, okay, which is higher than the hydrocarbons, ethers and haloalkanes which are having the similar molecular mass, comparable molecular mass. So that is due to this high boiling point of alcohols, which is mainly due to the presence of intermolecular hydrogen bonding. Here these alcohols which undergoes the intermolecular hydrogen bonding, so due to this which is having the more boiling point, but the hydrocarbons, okay, next ethers and alkyl halides, okay, which do not have these intermolecular hydrogen bonding. So as a result, the boiling point of these compounds which are less when comparing with the alcohols of comparable molecular masses. Next, another property. So here we can see the ethanol, okay, ethanol, methoxymethane and propane. So those are having the molecular masses. Here the ethanol is 46, methoxymethane also 46, and propane is 44, which is almost comparable molecular mass. Okay, if we consider the boiling point, which is in the case of the ethanol, which is 351 Kelvin, and the methoxymethane, which is 248 Kelvin, whereas the propane is only 231 Kelvin. So this is the boiling points of the alcohols, okay, and ethers and hydrocarbons. So among these, the methanol has only the more boiling point than these remaining compounds, because it is having the methoxymethane is 248, whereas the propane is only 231, but the ethanol is 351, around 100 Kelvin difference is there. Next, another property, that is the solubility. Okay, the solubility of alcohols Okay, in the case of water, that is due to their ability to form the hydrogen bond with water molecule. Okay, these alcohols can also form the hydrogen bond with the water molecules. So that the solubility that should become increases, and at the same time the solubility that should be decreases with increasing size of the alkyl group. If the size of the alkyl group increases, then the solubility that should become decreases, because the hydrophobic nature that should become increases. Okay, the several of the lower molecular mass of alcohols which are miscible in the case of the water in all proportions. The lower molecular mass of alcohols which are miscible in water all proportions, where the carbon chain increases, alkyl group increases, then the solubility that should become decreases. Here between the alcohol and the water molecule, the hydrogen bonding this way which can be takes place. The alcohol consisting the oxygen and the water molecule consisting the hydrogen. So between that the partial hydrogen bonding can be takes place. Okay, due to these the similar way the oxygen of water molecule and hydrogen of the alcohol. So between that also the hydrogen bonding can be takes place. So as a result, the solubility in water that should become increases. Okay, that only for the low number of alcohols. Okay, like methanol, ethanol, propanol, which can be soluble. As the alkyl chain increases, the solubility that should become decreases. Okay, this is about the physical properties and preparation methods of alcohols. Thank you.